Hello all, this is Nagendra here. In this video, we will discuss linear regression. What is linear regression? Linear regression is one of the most popular supervised machine learning algorithms. Let us have some clear understanding about this with small example. Let us consider a plane and we initialize some data points on this plane. These are the data points, and here the x-axis represents total number of objects and the y-axis represents the total price of objects. So if you could see here, the price of one object is 1 rupee and the price of two objects is 2 rupees and the price of three objects is 3 rupees. Suppose if we would like to find out what the price of 4 objects is, we could easily say that it is 4 rupees. How could we say that? We have said that just by analyzing the relationship among this x-axis and the y-axis. Here the price of the object, the total price is depended on the number of objects. The price of one object is 1 rupee, the price of two objects is 2 rupees and the price of 3 objects is 3 rupees. So based on this relationship, we could say that the price of 4 objects is 4 rupees. So this is how we can define some relationship, or we can find some relationship among the x-axis and the y-axis. Here the y-axis represents the dependent variables and the x-axis represents the independent variables, because this price is totally dependent on the x-axis data. So we call these data points as dependent variables and these as independent variables. So finding out or analyzing the relationship among the dependent and the independent variables is called regression. And representing this relationship with a line equation or with a linear line is called linear regression. So here we represented the relationship among the dependent and the independent variables with a linear line. So this is exactly what the linear regression is. We as humans could do this just by visualizing the data, but how could machines do the same job? That is where machine learning comes in. So what really happens in these machine learning algorithms, just like linear regression, is, just a second. So in machine learning algorithm, we build some model, or we could say a hypothesis, where we train this model with a given data set. So after training, this model can predict the unknown values for a given data. In every machine learning algorithm, we build the model and train that model with the data. So let us see how this model building and training works. So here, this is the data set, and this is the model we built for linear regression. This is exactly similar to the line equation that we studied in the earlier days. This model or hypothesis is exactly similar to the line equation y equals to m into x plus c. Here the hypothesis is determined by h of x equals to theta 0 plus theta 1 into x. This is exactly similar to the linear equation or the line equation y equals to mx plus c. Here these are the parameters that determine the line equation. So in this model, this theta 1 and this this theta 0 and this theta 1 are the parameters that are responsible for the formation of this line equation. So this model should be able to fit or represent the relationship between these dependent and independent variables. In this data set, the size of the house is independent variable and the price is dependent variable. So let us consider this plane with the data points. So what we want to do is to come up with values for these parameters theta 0 and theta 1, so that the straight line we get out of this must fit into this particular data. So that straight line should represent the relationship between this x and y. So for that, we need to find out the values for theta 0 and theta 1 in the above mentioned model or the line equation. So the straight line should fit in this into this data. So we need to find out the values for this theta 0 and theta 1 to fit into this data. So the question is now, how do we come up with those values of theta 0 and theta 1? So the basic idea of this algorithm is to choose theta 0 and theta 1 so that the line equation, the line should be close to y for a given x for a given training example. So these are the original values of y for a given value of x, and this line represents the predicted values of y for the given x. So the model which is going to produce the line should be in such a way that the distance between this predicted value of y and the original value of y must be minimized. So this distance between these predicted values and the original values is called the error of this model or the cost of this model. So the cost or the error of a model is defined as cost j of theta equals to y predicted. The y predicted is represented along this line and the original y, and to the whole power 2. Whole power 2. This square is just because the distance between this y predicted and y can be negative. To avoid this negative value, we are squaring this value. this model initially produces different kind of line equations, but the distance between the y original y should be minimized. So that is why this model tunes itself and produces, and because if this is the line equation that model produce, the cost of this model will be very high with respect to this. So this model has to tune itself and produce the line equation which has lowest cost, minimum cost. So that is the main motto of this learning algorithm. So the main objective of an algorithm is to minimize the cost, this cost. So algorithm must minimize this cost function. This is the cost function. That is sum of y predicted minus y original to the whole square, and this is the into 1 by 2m. M is the total number of data points. This is to minimize the cost function. We have added this 1 by 2 to easier mathematics calculations, as it is easier to minimize 1 by 2 of a thing. This cost function is represented as j of theta. So we must minimize this j of theta so to obtain a best fit line for this given data. Okay, so if in case this function seems a little bit abstract and you still don't have a good sense of what it's doing, let's go deeper into what this cost function j is doing and try to understand better intuition of this cost function. So far what we mathematically discussed is this is the hypothesis of a algorithm or a model that we build in the algorithm. These are the parameters that are responsible for the equation of the line or the hypothesis. This is the cost function we must minimize in order to get a best fit line. So our goal is to minimize this cost function j of theta 0 and theta 1. So let us go deep into this cost function. So let us consider a simpler hypothesis for better understanding. H theta of x equals to theta 1 into x, okay, and initialize theta 1 as 1, and these are the data points here. Okay, so what the model basically does over here is, so this model with the given theta 1 equals to 1, this model produces this line equation which best fits in this data. Okay, so the error of this model is almost equals to 0 as this line equation passes through all the 3 points present in this data set. Okay, so the cost of this model is almost equals to 0. Okay, let us take another case. So the cost of this function, just a second. So the cost of this model is almost equals to 0. Sorry, so this the cost of this model is equals to so if you can see here, the cost of the above model for a given value of theta 1 equals to 1, the cost is here, the cost of j of theta 1 equals to 0 for given value of theta 1 equals to 1. Okay, let's see another case. So if you can see here, this term we are considering theta 1 equals to 0.5. So with this value of theta 1, the model produces the line equation as this, unlike the earlier way. Okay, so in this case, the cost of this function, this model, is little bit more as compared to the earlier one. In fact, in the previous model there is no cost. Okay, but in this equation, in this model with a theta 1 equals to 0.5, we can observe here the cost is almost see, this is the cost. So as compared to previous model, we have, so in previous model when theta 1 equals to 1, it's almost 0. So now it's increasing, almost it is equals to 0.5, I think. Okay, this here the cost of this model it's going to be. Okay, so let us see another case also. So in this case we are considering the theta 1 value equals to 0. So in this case the model will produce a line equation almost along the x-axis. So in this case the cost of this model is little more than the previous model. Okay, little more compared with the previous one where theta 1 equals to 0.5. So this time the model cost of this model will be little more than this. Okay, so it will be here, I think. So if you observe here, the cost when we change the theta 1 value, the cost of this model is getting increased. Okay, this you have observed now, but our goal is to minimize the cost. So when is the cost function value is minimized? When theta 1 equals to 1. If we increase this theta 1 value to 1.5 or 2, again it is going to increase the cost. Okay, so but our goal is to minimize this cost function. We have to get that model which has the minimum value of cost. Okay, so this will be the cost function of a model. So if we initialize a model with the parameter theta 1 equals to 2 or something, 2, if let us consider. Okay, if we initialize the model with the parameter theta 1 equals to 2, so the cost of this model will be around, okay, just a minute, the cost will be here, I think. So this model has to reduce its cost and to obtain this as minimum as possible. Okay, from here to it has to get down here, that's this model. Okay, for that we need a technique called gradient descent. Okay, let us discuss that. Let us see what gradient descent is. Let us see here. this is the cost of the model, and this is the parameter theta 1. Okay, now let us suppose assume the cost function as, just assume, okay, sorry, assume this as a cost function of the model. Okay, if you initialize this model with a parameter theta 1 equals to 2, so in that case the cost of this function would be lying here, over here. Okay, it would be like around here, the cost of this model. Okay, here, around here. From here this model has to get down to over here where the minimum cost lies here. Okay, this minimum cost lies here, so this model has to move from here to here, the cost of this model. In that way it has to tune its parameters. But how does this model do this? This uses the concept of gradient descent. In gradient descent, what basically happens is it calculates the gradient or what we call derivative of this function, cost function, over here where we initialize with the theta. Okay, so the the derivative of this function would be like this will be the slope or the derivative of the cost function over here. So this slope tells that the cost function is increasing here, so we have to decrease in this direction. So in this case what basically happens is the slope is actually increasing, but the slope must be at this level. At this level it has to obtain the slope. So the gradient of this function must be equals to 0 but here the gradient of this function is actually in increasing order, so we have to decrease the we have to decrease the derivative of this function. What here derivative is called the gradient. We call derivative as gradients. That's why we descent means decrease, so we have to decrease the gradient of this function, so that's why we call gradient descent. So it has to come from here to here. Okay, this gradient descent is mathematically represented as, okay, here. Okay, see, the gradient descent is represented as here, the new value of theta equals to the old value of theta minus LR, means LR learning rate of the algorithm, into gradient of this cost function. This is what gradient of the cost function, this is, okay, the derivative. So in this case, if we initialize this model with this theta value equals to 2, the derivative of the model will be here. Okay, if we substitute the derivative here, and the learning rate will be how fast it has to move from here to here. Okay, how fast it has to take steps, and the old value will be 2. So 2 minus learning rate into gradient of this cost function. So if we apply this formula, we'll get some new value over here. Okay, from here to here. Again applying this formula, it will come from here to here. Again in the if we repeat the same steps, it will automatically come to this minimum location, minimum derivative, minimum gradient. Okay, after obtaining here, the gradient value will be equals to 0. So in this case it won't change again, so new value will be always old value. So after obtaining here theta value equals to 1, it won't change again, because the gradient at this particular point will be 0. So we'll get the theta value of 1 as the minimum value. So that's how this gradient descent works, and finds the theta value and gets a better line that fits into the data set. Okay, this is how it works. So far I have discussed a lot more regarding linear regression, how does it works, what are the concepts we use. So in the next video we'll see all these things as a practical example through coding. Okay, so far if you have any doubts or confusion, please feel free to comment down below. Okay, see you in the next video. Thank you.